planned action.
We're not doing one now. One was on your own unless we get to it after lunch.
Did we already do practice session?
No, we did not.
No, man, listen up.
Hey, focus.
All right.
Next week.
So I am happy to do practice test 1 if you are cooperative and we get it done. But you need to get busy. We're going to do 2 today. Today's 2. Here we go. Practice test 2. I'm given these functions. And then I'm asked some questions. Now remember, you're supposed to be doing this on a piece of loose leaf paper. It's going to get way too smushed and disorganized on here. All right, question number 1 says, find m of n of x. Oh my gosh, we just did that. That's what somebody asked about on the quiz, right?
No.
So what do? This says take whatever n of x is, which is x squared plus 2, and put it into m. Take n and put it into m. So put it right here, put it into m. So that would be 4 x squared plus 2 minus 3, which is 4x squared plus 8 minus 3, or 4x squared plus 5.
Yeah.
And that is your answer. It's exactly like the quiz question, except I'm using different letters. All right? B, m of 2 minus n of 3. Okay, this is a 2-part problem. How do we find m of 2? Plug 2 into m, into the x part of m. So what do we get if we put in 2? 5. So this is 5. Now we're going to find n of 3. Okay, what do we get when we plug in 3 into n? 11. And the problem tells us we're supposed to subtract those two numbers, so our answer is -6. You should not miss that problem. C. This was on the quiz too. Nobody asked about it, but this was on the quiz. This says find n of 1. We always start here first. Find n of 1. All right, what's n of 1? 3. So this is 3. So we're finding m of 3 now. This is 3. So m of 3 would be
9.
9. That's the answer to the question. So this problem, we put 1 into n and get an answer. And then that answer goes into m for the final answer. And finally D. D says multiply m of x times n of x. Do not make this hard. What is m of x? 4x minus 3. N of x is x squared plus 2. Oh shoot, what are we going to have to do? FOIL. So outside, or first, I'll start with first. First gives me 4x cubed. Insides give me -3x squared. Outsides and last. I did that in a little bit different order so that my answer came out in what we call descending order. If it didn't come out that way, you would have to make it that way, change it that way. 4x cubed, we multiply 4x times x squared, and then minus 3x squared plus 8x minus 6. Find implicit functions. Okay, so what does this mean? Pretend you're at the dinner table. Mom and Dad say, what'd you do in school today? And you said, I found implicit functions. Mom will know what that means, but you have to explain it to Dad, right? How will you explain it? How do we find implicit functions? We get y by itself. So we will subtract 2x squared and take the square root. And when we do the square root, it is plus or minus. Do we simplify what we end up with? No, not unless it's obvious that we can do it. It is certainly not obvious in this case. Do not try to simplify that. Number 3, find domain. Just in case there's anybody in the room that forgets the rules, denominator cannot be 0. Whatever is under the radical must be greater than or equal to 0. Those are the rules. If you have not yet memorized those, I would suggest it before next Wednesday. All right, so A, I have a radical in A. So my rule says whatever is under it must be bigger than or equal to 0. Which means what's my domain? X is greater than or equal to 1. Now if you want to do that in interval notation, you can, but I'm not going to force you to. I mean, it's not going to be an expectation. B, it has a fraction. What's the rule for fractions? Denominator cannot be 0. Which means 3x cannot be 1 and x cannot be 1/3. What about C? Oh, come on now. All real numbers. Gabby's right on it. All real numbers. Why is C all real numbers? It doesn't have a denominator and it doesn't have a radical. So unless it's some freakish problem, the domain is going to be all real numbers. And I'm not going to trick you. You're not going to have a freakish problem. If there's no radical and there's no fraction, your domain is going to be all real numbers. Hear that? We shouldn't miss that question. All right, D is a harder one because it has both a radical and a fraction. So what do I know about the denominator? Cannot equal 0, so x cannot equal 3. That's part of my answer. But I'm not done, because I also have a radical. And what do I know about what's under the radical? It's got to be greater than or equal to 0, which means x is greater than or equal to -2. On that answer blank, you will have two things. Greater than or equal to -2, not equal to 3.
If there's a radical in the denominator,
Then you do everything the same except it can't equal 0. Because you can't ever have a 0 in the bottom. So whether it's under a radical or not is irrelevant.
okay, so it's just greater than, but no equal to.
Right, right. Otherwise it would be exactly the same thing. All right, part 4, we're sketching. First of all, you will not have your note cards. This is not an open note test. So you need to know what these shapes are. Because when you are asked to sketch this, the first thing that pops into your head is, okay, it's a V, right? We know it's a V because it's an absolute value and we've memorized that. But this V, see, the normal V would be here like this.
Goes up.
This V has been moved. These numbers, when you add and subtract, you move your picture. So now you got to remember, how does it move? The 2 is grouped with the x. X plus 2 does what? Moves you
to the right.
to the right. So it's going to move you, oh wait, no. This is going to move you to the left. This is going to back you up 2. Remember, when it's hooked to the x, it does the opposite. So since it's x plus 2, we're actually going to back up. What does this extra plus 1 on the end do?
You're going up.
It's going up 1. So you have a v that's over 2 and up 1. Alrighty. Now we've got our handy dandy sine curve. So I'm going to go ahead and sketch in my sine curve. That's my original sine curve. Is that okay with everybody? Going through the origin like that, are you okay with that? Now what am I doing to it? Moving it up 2. So this point is actually going to be up here now. Moving every point up 2. So I have my nice little sine picture, but it is raised up. Does that look okay to everybody? So it used to bounce back and forth between -1 and 1. That's what the standard curve does. What does this one do now? It bounces back and forth between 1 and 3 because it got picked up 2. C. Okay, what shape? First of all, what shape are we going to have? We're going to have parabola. Everybody's got that. But it's moved, just like our V got moved. Our parabola's getting moved. How's this one getting moved?
To the right one.
To the right one and down 1. So you're going to have a parabola that used to be here, but now it's gone right 1 and down 1. So it's like this. This is the point 1, -1. It went right 1 and down 1. Everybody see that? Right? Go opposite of the x. Looks like minus, but I'm going to go plus. Then down 1. Oh, look at D. It is another parabola, isn't it? Oh, no, it's not. It's a cube. That's not a parabola. What shape is that? That's a squiggly, normally squiggling through the origin, right? What did we do here when we put that +2 in parentheses with the x? It went left 2. So we're going to have the same squiggly shape, but it's going to squiggle through -2 instead of through the origin. Normally, it squiggles through the origin. Everything got shifted 2 units left, so it's going to squiggle through -2. E. What's the shape? Yep, Raven, you're exactly right. It's this. But what have I done to it? I've moved it. How have I moved it? Left 1 and down 2. So I'm going to take that shape and I'm going to go left 1 and down 2. So it's going to look like this. This is the point, -1, -2. I go left 1 and down 2 and graph my shape. Now I have my piecewise function. Remember, your test is exactly like this. So you are going to have to do a piecewise function. All right. Oh my goodness, what shape is that first one? Y equals 3x minus 4. What is that? That's a line. And it's a messed up line, so I'm going to graph it like I graph lines normally. It has a y-intercept of -4 and a slope of 1, or 3, 3 over 1. So I'm going to go up 3 and over 1, up 3 and over 1, and that is going to be my line. So far, so good. But it's called a piecewise function because we only want a piece of it. So we're going to put a dot where? Where x is -1. Now, kids, that's right here. This is where x is -1. So go down to your curve. There's your dot right there. It's where x is -1. It's an open dot. And I got to erase now. What am I going to erase?
The right.
I'm going to erase the right. I'm going to erase all this work I did right here. Everybody on board? What's this guy?
V.
That's a V. Now, if that's all I had, it would be this V, right? But it's got a +1 on the end. What is that going to do?
Move it up 1.
Move it up 1. So I'm going to have my same old V, but it's been picked up 1 because of the +1.
Yeah.
Now, where am I going to put a dot on that? Where x is -1. That's right here. So I'm going to come up and put a dot right there. That's where x is -1. And then I'm going to color part of it. Which part am I going to color?
You erase the left.
I erase the left. Color the right. Keep the right. And we're done. When we get done with this, we're almost done. We only have one more part to go. Okay? All right, let's finish it. Then when you come back, we won't have a lot of time because we're a little late going to lunch, so you'll be a little late coming back, but we can get one started at least, huh? All right, find the horizontal asymptotes, vertical asymptotes, and holes. So horizontal asymptotes, vertical asymptotes, and holes for the problem that looks like 2x plus 1 over 3x minus 4. This should be easy for you. Tell me any of those for this problem. Vertical asymptote is at x equals 4/3. How did Gabby know that? Vertical asymptotes are what makes the denominator 0. So 3x minus 4, what would make it 0? Do you see how she got 4/3? You know, there are some things you just got to remember, people. You can't walk out of the room and forget everything. You got to remember that the denominator is 0. That's a cannot be, that's a vertical asymptote. All right, who can give me one of the other ones? What? My horizontal asymptote is that y equals 2/3. Remember, when you do horizontal asymptotes, if the powers match x over x, not x squared or x cubed over x or something, they're x over x, then you just build the fraction. Y equals 2/3. How about holes in this problem? You don't have one, because the only way you can have a hole is if what happens? You factor and cancel. Nothing factors, nothing cancels. No holes. All right, B. I can factor the top, but did factoring the top do anything for me? No, because still nothing will cancel, which means I have no holes. What about vertical or horizontal asymptotes? X equals -5 is a vertical asymptote because you can't let x be -5, right? Now, caution, if you're not putting x equals and y equals, you're losing half credit every blank. Make sure you're putting equations. Verticals are x equals, horizontals are y equals. Speaking of horizontals, does this problem have a horizontal asymptote? No, because look at the original problem. It is x squared minus 9 over x plus 5. These powers do not match. So we have rules for that. If the power on top is bigger, there's none. If the power on top is smaller, it's 0. Always. So if they match, you compare them. You make a fraction out of them. If the one on top is bigger, there's no horizontal asymptote. If the one on bottom is bigger, it's automatically 0. Y equals 0. You are not hearing that for the first time. All right, last one. Here we go. Then you can go to lunch, all right? So let's see if we can get this one done. What's your suggestion? Factor it out. So the first thing I'm going to do on top is pull out a 2, and now I will factor. Got my difference of squares up top. How about the bottom? How does it factor? X plus 5 minus 4. Everybody okay with that factoring? I'm all set up, ready to go. Oh, what do you notice? We can cancel. And as soon as you cancel, you know you're going to have a hole. Now, where will the hole be? Look what you canceled out. +4. So my hole is going to have an x-coordinate of +4 because that is the root or the factor that I canceled out. The hole is a point, though. It's not an equation. These guys are equations. This guy's a point. So I need a y. Where am I going to get my y part of that point? I'll plug 4 in right here. So I'll have 2 times 8 over 9. I put in 4. So that gives me what, 16/9? There's my hole. Now look at this. We have any vertical asymptotes in that? Yes, we do. Where is it? X equals -5. How do we get vertical asymptotes? It's where the denominator equals 0. Does it have a horizontal asymptote? Now pay attention, look at the powers. Do the powers match? Yes. So you have 2x squared over 1x squared, or you have 2x over x. So what happens? 2x over x would mean your asymptote's at y equals 2. 2x over 1x, 2 over 1, y equals 2. That is practice test 2. Alright, so let me calculate, and I want you back to 1. I need you back to 1.